Okay, so this video is going to go over the file compression quiz practice quiz number 1. So I'm going to blow this up so we can read what's going on here. Even that seems like I should make it a bit bigger, but let's just go with it. So it says in natural languages there are big differences in what letters are most common across words. In the Spanish language, the letter E is the most common, occurring 12.2% of the time. The letter K is the least common, occurring only 0.01% of the time. That's why the Huffman coding algorithm can help to compress natural language documents. Huffman coding reduces the amount of bits required to represent data by choosing new bit codes for each source symbol and choosing short codes for the most frequent source symbol. Here's a Spanish code, or Spanish word encoded with Huffman coding. These are the codes for the letters in the alphabet. Okay, so A is represented by 011, C 11011, O 1111, S 1110. Decode the word according to the bits. Okay, so when we look at this, we've got 11. So which ones up here would start with 11? Well, A wouldn't work. C, we got 11011. That could be the first letter. That works. There isn't a 1. Isn't 4, and then there isn't a 3, 1s, and a 0. So the only thing that this can start off with is a C. So you're taking this, cross off C and E right away. So then we've got 0 and then a bunch of 1s and then a 0. Well, the only next one that starts with a 0 is an A. So you got 0, 1, 1 right here. So you can cross off the D because it can't be an O. So it's either A or B. Chaos. This one's an S, so there's no zeros in here. So I think we were right here. So we got 1, 2, 3, 4 is our A, or is our O, and then we would have 1, 2, 3, and a 0 as our S. So the answer is A, chaos. 2, compression algorithms vary in how much they can reduce the size of the document. Which of the following would likely be the hardest to compress? So a document created by 10 monkeys banging randomly on a typewriter for 10 hours, a book of nursery rhymes, the Declaration of Independence, and lyrics of all songs. Okay, so when you're doing rhymes or songs, you have a bunch of words that tend to repeat. So B and D don't work. C, I've got the Declaration pulled up here. This is the most famous line from it that everybody knows, right? We hold these truths to be self-evident, that all men are created equal, that they are endowed by their Creator with certain unalienable rights, that among these are life, liberty, and the pursuit of happiness. Well, in this sentence right here, I can already see that, and that. We could compress that down into just one symbol to represent the word that, and that would help compress it all down. So though the Declaration would be hard to compress, there's definitely things in here that can compress. So your answer's got to be A. And the reason it's A is it's all random. You can't compress a file that's completely random. So that was your cue that 2 is A. 3, Merlin has a file with his favorite wizard spell, abracadabra. So just looking at this, if you were going to compress this down, you look to yourself, well, A occurs 1, 2, 3, 4, 5, 6, 7, 8, 9. That occurs the most, so if you're going to compress it down, you could do that. In a standard uncompressed representation, each letter would likely be represented with its ASCII encoding. A is this, B is that, etc. The Huffman coding compression algorithm reduces the amount of bits required to represent data by choosing new bit codes for each source symbol and choosing short codes for the most frequent source symbols. If the computer applies Huffman coding to the wizard spell, what letter? So it's A. again, you can just, that's the most used, so that's what would be compressed. Okay. 4, so we're looking at lossy and lossless. Okay. Let's see here, what does it say? The following processes are used by video compression algorithms categorized by, so you would write down either lossy or lossless on each line. So instead of storing every pixel for every frame, the computer stores the difference between the pixels. So lossy is where information is completely lost. Lossless, both, by the way, both of them are compression types, different strategies on how you can compress. But with lossy, your data is lost. With lossless, you can get your data back. So anytime you see anything like the word difference, it means that they're subtracting the difference between the two pixels. And if you have the difference, you could get the original back. So that's lossless. 2, the computer replaces frequently occurring patterns of bits with shorter representations, remembering the replacements in a table. That's kind of like this one. That would be lossless. You're not losing any information. It's just getting changed into smaller information, but you could go back to the original. The computer detects when a person is the focus of the video frame and stores less information about the background. So that's just completely losing information of the background that you could never get back. So that's lossy. So you got lossless, lossless, and lossy. 3, consider these files: a 3-second audio recording of a baby's first word, a 30-second recording of a baby's first steps. Is it possible for the 30-second video recording to have a smaller file size than the 3-second audio recording? Yes, but only if the 30-second video is recorded with a smartphone. No. 2 or B, yes, but only if the 30-second video is saved using a patented standard. Yeah, I don't know what a patented standard is. C, yes, if the 30-second video is compressed with a lossy compression algorithm. So that sounds okay to me. D, no, the 30-second video will always take up more space. Now, I definitely would say C, you can compress it and lose information. I do have an image somewhere of a video that I compress. Let me see if I can find it. I wanted to show this to the class, so let me, I can just do it right here, and you guys can see how, I think I stored it in the compression folder right here. And I'm going to put this compression example. So look at this real quick. So I made a video that was normal, and it was 114 megabytes, and then I compressed it down into 46.1 megabytes. So that's a huge, that's almost, that's over 50%. It's probably more like a 60% compression right there. And so, you know, it is possible, but you're going to lose a lot of your data, and then the 30-second clip's going to look choppy and not very nice. Probably, I can't be sure, but I'm guessing probably. Consider the adjacent image. This distorted image is an example of. Okay, so this right here, you've got this part of the cat's head, and then you blow it all up so you can see each pixel. That's an example of pixilation. And I believe this is in here too. Yeah, so here's your picture of your dog at the computer, and this is his nose like blown up so you can see each picture and each kind of shade in the picture. That's an example of pixilation. 7, file type, file size, file length, and the file title are all examples of, well, this is just a definition. This is metadata, but this is an example of metadata. So you got the file name, type, date, modified, size. So you don't know what's actually stored in the file, but this is your metadata: name, date, type, size. Okay, so you're just gonna have to memorize that. 5, a computer program is originally designed to store customer identification using a 5-bit binary sequence. As the number of unique customers grows, the program must handle a far greater number of identification than were originally possible. The new program must handle 10 times the original customer size. Which of the following binary sequences uses the smallest amount of memory and can still handle new requirements? Okay, so it stores 5 binary sequences, so it's probably best if I just showed you what I wrote out. So 5 bits, 1, 2, 3, 4, 5, and I've got 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4. It originally could store 16 plus 8 plus 4 plus 2 plus 1 bits, and then you need 10 times that, so 31 times 10 is 310. How many of these do you need? And so, you know, you need 2 to the 8th, which is, if you add up all these, it's 511, which is 1 less than 2 to the 9th, right? So 511 will hold 310 bits. But in order to figure out the number of bits you need 9. Which again is kind of confusing because you've got 8 here, but you got to remember you start at 0. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9 bits of data right there. So that's how I figured that out. And again, I'm going to upload this so that you guys have the answers. And finally, consider the following 4 binary numbers. Which of the following displays the numbers in ascending order? Ascending order is from lowest to highest. Descending would be highest to lowest. Like, so think about steps. You're ascending the steps, you're going up a staircase. If you're descending the staircase, you're going from the top to the bottom. So that's just something that you'll have to know when you're taking this. So when you look at this, if you're going from low to high, you probably want to find the smallest number. Well, the smallest number in here is easy to find because, you know, remember you're just adding these up to get your decimal representation of these. If you want to do it the long version and find the actual decimal value for each of them, you can. But you can just do it by your eyes, right? I know just for a fact that that's the largest number right there because 1, 1, 1, 1 is hit. Whereas this one, 1 and then 0, that's turned off. This is the second largest because 3 of these are here, and this is the third largest because 2 here. So this is the smallest because 1 gets hit, but then it automatically turns off. And then this is the second, this is the third, this is the fourth. So yep, your answer is going to be A here. And again, you could break all this down into its decimal version. But you could just do it how I just said. You know, this number right here is greater than this number because this right here is turned on and this right here is turned off. So anyway, your answer to 9 is A. And I've got all this stuff stored on Schoology, so you guys can you know, just look at the answers if that's all you need to do. So this video is done.